Ooh, lesson 2-1, solving absolute value equations and inequalities. We're here on page 73. Page 73. So, quick recap on absolute values. You guys know what absolute value is it makes the value positive, or you could say the distance from zero. You could say it that way too. So, if I said the absolute value of 3, well, that would just be 3. If I say the absolute value of negative 3, well, that's also 3. Now, the absolute value of x. Actually, I could write this as a piecewise function. I could write it this way. I could say it is x if x is greater than or equal to 0, because then it would just be itself. Right? But you would have to negate it if x was strictly less than 0. So, for example, if x was negative 3, you have to take the negative of the negative 3, which would make it 3. Oh, yeah. And real simple graph here. Let's do x, y. Let's go. Right. So you guys know what shape graph this would make. If x is already positive, the absolute value just makes it itself, right? So 1, 1, 2, 2, 3, 3. Like, see if I make an xy table. X, y. This is for f of x equals absolute value of x. Well, if x is 0, 1, 2, 3, then the y value would just be the x value. Right? But, say if you go into negative territory, let's say make a different xy table. Right? If you have x is negative 1, negative 2, negative 3, right? Well, now the absolute value is going to be 1, 2, 3. So it's like negative 1, 1, negative 2, 2, negative 3, 3. So line them all up. Just like that. All right. There you go. There's your classic V curve. This is for y equals absolute value of x, f of x equals absolute value of x. All right. So that's it. All right. So now let's make this a bit more exciting. All right, what if we have like a whole equation, like a whole expression, and there's some absolute value bars that show up? So I'll go through these examples. The first example says, all right, we got, so example 1. Okay? So 2 times the absolute value of 5x plus 1 and then minus 9 is all equal to 4x plus 17. Right? So there might be one, maybe two values of x possibly that could make this true. So we're just going to go through our algebra rules and see how this plays out. So you got 2 times the absolute value of 5x plus 1. Right? Maybe I'll add this 9 over. How about that? Right, so that's equal to 4x be plus 26, I think, right? Right. Now, I do see I could extract a 2, or I could divide everything by 2. Could I do that? I could say, like, divide this side by 2, divide this side by 2, right? And then each coefficient divided by 2. Right, so it could go absolute value of 5x plus 1 equals, say this be 2x plus 13, right? See, is that what they're suggesting doing? Right. Um, yeah, actually, yeah, right. Right. So there's some blanks in your book, but it looks like the format they're going for. Now, here's where it splits into maybe like a case 1 and a case 2, because all this inside stuff, the 5x plus 1, is going to split 2 ways. Right? Yeah, do this there. Right? That 5x plus 1 there itself might be 2x plus 13, and that could go on to solve what is x. But that 5x plus 1 might also be the negative of all this over here. So I could say that, or you could, yeah, okay, let's do it. Okay. Negative and then 2x plus 13. That could also be true if you didn't want, right? Then I have to distribute this negative, right? Now, play the rest of this out and see if it works. Right, so let's see, subtract 1 from both sides, minus 1, minus 1. Here, while I'm at it, I'll subtract the 2x over here, so minus 2x from both sides. Okay. And on this side, it's going to give me, okay, gives me 3x over here. And what's this, a 12? Divide both sides by 3. Again, x is equal to 4. All right, so hold on to that. It's probably going to work. Right? But let's try over here. So I got 5x plus 1 equals negative 2x minus 13. Subtract 1 from both sides. I'll add the 2x while I'm at it. All right, so that's going to give me, here's 7x, and here is negative 14. divide both sides by 7. Getting x is -2, right? Right. Now, what I do want to do, like for this chapter especially, is once you get solutions, check those solutions. So go back to the original statement, which was way up here. Plug in those solutions and make sure they do work because sometimes they don't. And we'll have an example of that later. But so the original statement when 2 times the absolute value of 5x plus 1, the whole thing minus 9 is equal to 4x plus 17. Right, so let's test these two solutions. Right, so it should be, well, okay, let's test 4. So if I plug in 4 right there, let's see, does that work? Oh, and that was also 4 right there. Right, so we got 2 times absolute value of 5 times 4 plus 1 and minus 9. Is that equal to 4 times 4 plus 17? Right, right, so 2 times absolute value, well, this would just be 21, which the absolute value of 21 is 21, right? And then over here, for 16 plus 17, all right, we're testing to see is this true. This little question mark with that equal sign right there. Right, and then, well, absolute value of 21 is 21 times 2 would be 42. So this is 42 minus 9. Is that equal to, and then this is what, 33, I think? Right? So let's see, what's 42 minus 9? Hey, that is 33. Okay, so 4 is part of the solution set. So 4 works. Okay. We also got what, -2 right here. Okay, let's try that one. Okay, so same thing. We got 2, then absolute value of 5x plus 1, whole thing minus 9 equals 4x plus 17. Okay. I'm going to plug in -2. Here, 2. All right, so 2 times 5 times -2 plus 1. Absolute value. Right? That's 9. Is that equal to 4 times -2 plus 17? See if this works. So 5 times 2, or negative, that's -10 plus 1. I think this whole thing would come out to -9, right? So 2 times the absolute value of -9, then minus 9. Is that equal to, see, -8 plus 17? Right, so this is 9. 2 times 9 is 18. 18 minus 9. Is that equal to -8 plus 17? That would be 9, right? Yeah, 9 is equal to 9. Okay, so that would work too. Right, so -2 also worked. And hang on to that idea because those solutions don't always work. But in this case, it did. Right? So I can say as the answer x equals, and then in curly brackets because there's two discrete answers. You got -2 works from here. And also I had 4 works from before. Right? So those are my 2 solutions. Again, I solved that out before a few minutes ago. So that's right there. Okay. And then as a solution set, I would write like that. Little curly brackets to indicate 2 discrete answers. All right, so there's one example done. What we got next here? Example 2. Ooh, what is this extraneous solution? What is that? So, think it. Well, it's extraneous if it doesn't actually work. Wait, I know they said that somewhere. Oh, here it is. Right. An absolute value equation has one solution. If one of the answers does not meet the constraints of the problem, such an answer would be an extraneous solution if it does not actually work. Right. So, example here, we got example 2. Here, I'll spell the word extraneous. Now, you know this is going to be extraneous. We kind of know ahead of time, right? Because this is one of their examples. So 2 times absolute value of x plus 1, and then the whole thing minus x equals 3x minus 4. All right. So here, maybe I'll add x over, add x. That gives me 2 absolute value of x plus 1 is equal to 4x minus 4. Right? I do see this coefficient of 2. I could just go ahead and knock that out. Divide by 2, 2, 2. Right? I got 3 separate terms. I can divide them all by 2. That should be a valid step. X plus 1 absolute value is equal to this now be 2x minus 2. Okay? Now here's where it's going to split. Right? Because the idea is plus or minus. So on one hand, the x plus 1 might actually be 2x minus 2. Right? But maybe the negative is true. Maybe this whole x plus 1 is actually the negative of 2x minus 2. Okay? In which case I have to distribute the negative. Okay? So let's play this out, each one. So it could, let's see, maybe I'll minus x. I'll say plus 2 plus 2. Right, so that gives me 3 equals, and this would be x, right? So that's probably one of the answers right there. Right? And then over here, I'm getting x plus 1 equals negative 2x, and then minus minus would be plus 2. Here, I'll do plus, whoops, get ahead of myself, plus 2x, plus 2x. I'll subtract the 1 while I'm at it. So it gives me 3x, and then, okay, this would be 1. So divide both sides by 3, x should be 1 over 3, right? Right, so just doing the algebra, just follow the algebra rules. Okay, we got two solutions, but remember, go back and check your answers and see if they actually work in the original statement. So let's do 2 times, and then I'm going to spell it out, right? X plus 1 minus x equals 3x minus 4. Okay, so one of our solutions was x equals 3. So, so 2 times, and then 3 plus 1, which of course is 4, minus 3 equals 3 times 3 minus 4. And I'll put a little question mark because I'm not sure. We're testing. It's probably going to work, but maybe not. Okay, so this bit is 4 times 2 is 8. I think this whole thing is 8 minus 3. Is that equal to 9 minus 4? Well, 8 minus 3 I know is 5. And 9 minus 4 is also 5. Yeah, check. So that works. So that means that 3 is a solution. Okay? In fact, if this was graphed out, I'll show you guys a graph here in a minute. Um, the like if I said y equals this is a function and then y equals this is a function, like two separate graphs, they would cross at the coordinate 3 comma 5. Right? So where x is 3, y is 5. Right? Right, so let's test this for another one. Okay, what if I plug in what was my other solution? It was 1/3. 1/3. Okay? So let's see, does 1/3 work? What if I plug in 1 over 3, and then 1 over 3, and then 1 over 3? See what happens. And so I got 2 times absolute value of, okay, got 1/3 plus 1. Now, 1 here, I'll save myself a step. Is that same thing as 3 over 3? Just giving a common denominator, I'll myself add the next step. Then minus 1/3, is that equal to 3 times the third, and then minus 4? We'll find out. Right, so this looks like 4/3. This is 4/3. And then times 2, this whole thing would be 8/3. Then we've got minus this 1/3 over here. Right, is that equal to 3 times the third is 1 minus 4? All right, keep going. Okay. So then 8/3 minus 1/3, that would be 7/3. Is that equal to 1 minus 4 is negative 3? Fail. So that did not work. So that means that this 1/3 is actually not the solution. Well, that's interesting. So even though I used algebra rules and I got two solutions out of this, one of them actually ended up working, and the other one, I could say x equals 1/3 is extraneous. It's not actually part of the solution. So the full solution is just this, x equals, and then the only one that worked was 3. Right? And the coordinate would be 3, 5. Let's show you guys exactly what that looks like as a graph. Right? So if I say y equals this and y equals this, now I did this on Desmos ahead of time. Let's see, 2 times absolute value, it's 1 minus x, 3x minus 4. All right, that boring. Okay, there's the two graphs. It's like y equals 1 and y equals the other. And where those two graphs are equal to each other, it's to say where they cross would be a solution. So I see a solution right here. Oh, look, it's at 3, 5. So over x value is 3, y value is 5. Bam, exactly what we found. Right? Now, the sort of extraneous solution was x equals 1/3. See where the graphs definitely do not cross at 1/3. Now, interestingly, this red sort of V-looking curve, which has different slopes because it's got this minus x that changes the slope on each side of this. Right? Maybe I could say it's not vertically symmetrical. Right? But if you took this left leg and you extrapolate it, kept going, it actually would cross this blue line at the x value of 1/3. So that's kind of interesting. But of course, the graphs don't cross. Right? So it's a little side thought, right? Right? Um, Now, what about the back to? I'm going to backtrack back to example one. Remember how? Okay, so we did this one a few minutes ago. Remember how there actually were two solutions and they both worked before? So what would that look like on a graph? Because if it does work, then there should be two places where it crosses. Okay, so I went ahead and graphed that also. We backtrack a little bit. So this was example one, right? Those like y equals that, right? So this red curve is a classic V shape. The blue line actually does cross there twice. I have to back way out so you can see both places there. But my solution was x equals -2 and x equals +4. So yeah, here's x equals -2, where they cross right there, and x equals +4. Way up here where they also cross those dx values. Yeah, okay, so that was example one where they worked. Example two where, okay, well, okay, we're moving on from that. All right, so Bert, so we got two examples down. Let's keep going. Example three says the empty set. Now, what that would mean is that there are no valid solutions. Could that be? Could they give you an equation where there are no valid solutions? I mean, imagine graphically that there might be a place where the two graphs just don't cross, and maybe it's like that. So I'll say example three. We got absolute value of 4x minus 7. Okay, the whole thing plus 10. And this is supposed to be equal to 2. Right? Okay, so let's do some algebra. So you subtract 10 from both sides. So now the absolute value of 4x minus 7 should be equal to -8. And okay, right here, now you know this whole thing is definitely going to fail because the absolute value of anything cannot be a negative number. Right, so this would definitely have no solutions. Now, what does that look like on Desmos with graphing? All right, so I'll say y equals 4x minus 7, the absolute value of that, and then plus 10, that would be one equation. And then y equals 2 will be another equation. Right, so I graph both of those. Interestingly, I had to type y equals 0x plus 2 to give me this value of y equals 2. It's the same thing, just a constant blue line. Right, and then this other absolute value, okay, I have to zoom out to see it. It's a V curve that's way the heck up here. Okay, yeah, so those two curves are definitely never going to cross. Hence, we just found algebraically there is no solution to that. Right? So it means the same thing. All right, so we are looking. Let's keep going. Got example four, write and solve an absolute value equation. All right, so we're looking here, like a real life example. The NFL regulates inflation or air pressure of footballs used during games. Footballs must have an air pressure of 13 pounds per square inch. That's called PSI. Right? Plus or minus zero point 0.5 pounds per square inch. Right? So there's an acceptable like, range of values. Right? What's the greatest or least acceptable air air pressure of a regulation NFL football? Right? Right, so can you rate the task in your own words? I guess that's just been me explaining this. What's the method to explain this task? And there might be different ways to go about this. I might say something like this. I might say that uh, the pressure should be 13 pounds per square inch, yeah, plus or minus zero point 0.5 pounds per square inch. Okay? Now you can write this as an inequality. Now the pressure, maybe I'll call it, maybe P or X. P or X, I'll just do P for pressure. Uh, I'll say equals 13, and we'll just drop the units. Right? So you guys know that the numbers have units of pound per square inch. Say plus or minus zero point 0.5, okay? Now, here's what I'm going to do. I'm going to try to isolate just this plus or minus bit, and I'll be able to get an absolute value function at that. So I'll subtract off the 13. So the pressure minus 13 psi equals plus or minus zero point 0.5 psi. Okay. Now, here's where I'm also gonna okay, let's introduce some absolute value bars. Okay, that's to say if I take the absolute value of pressure minus 13, so whatever the pressure is, if I subtract off 13, then ideally this should zero out, right? It should zero out. The closer it is to zero, the better. Okay? Now, what do I do with the plus or minus? Here's where all right, here's where I make this transition from this line to side. So I'm gonna say this absolute value should be less than or equal to zero point 0.5. Right, so I lost the plus or minus, right? But I'm sort of like restating it as an absolute value. It's kind of this, right? Like here, let's do some guess and check, right? Because I think this makes sense if you think about it. Right? Like, what if the pressure was like 14 pounds per square inch? Well, that would not be regulation because 14 is not within the window. So what if I plugged in 14 here? See, 14 minus 13, that would be 1, which is greater than zero point 0.5, which is not good, and so it would fail. Okay, so this difference has to definitely be less than or equal to the zero point 0.5. What about this? What if you took a football, here, draw a football, actions, right? Just guesses, you know. Right, and it came out to like 13.1 psi. That would definitely be within the window, 13.1. Right, so let's try it. 13.1 minus 13, that's zero point 0.1. Okay, so it's not zero, but it's tiny, tiny. Less than zero point 0.5. Okay, yeah, it checks out. So we get. So this should be the answer right here. Right, that could explain the allowable pressure as an absolute value equation. Right. Oh, they also how could yeah, how could you write this different ways? We'll do a number line and then we'll do like a domain restriction right now. Okay, so as on a number line, let's do like this. Let's go 12, 13, 14. Okay. So it's allowed to be uh, 12.5 would be the smallest allowable. Okay? And 13.5 would also be allowable, but that would be the large side. Okay? And anything in between is definitely allowed. Ideally, if it's really close to 13, or if it is 13, that would be the best, right? So look for 13 psi and a plus minus a little bit. Okay, so there it is on the number line, put P for pressure on this number line. Okay. Here, let's do a domain. Right. So in set builder notation, you could write it as pressure such that pressure is greater than or equal to 12.5 and less than or equal to 13.5 and psi. Okay. And interval notation. Okay, I'm going to use these little square brackets because it's allowed to keep these endpoints. It's a 12.5, comma, 13.5, and then close with the square bracket. Yeah. All right. So boom, 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 boom. There's 4 different ways to represent the exact same information. All right, so that was example 4. Boom. All right, example 5. Solve an absolute value inequality. Okay. So which actually I guess we sorted it one already, right? Okay. But sometimes these are a bit more exciting. Sometimes instead of between something something, sometimes it's like either less than a number or bigger than a bigger number. Right? Okay, let's see if this one turns out. Yeah, I don't know. I forget if it does. We'll find out. Okay, so we got example 5. Got absolute value of 4x minus 8 and a whole thing. Okay, minus 5 should be less than 11. All right, so add 5 over plus 5 plus 5. So absolute value of 4x minus 8 has to be less than, strictly less than 16. Okay. Here's where it's going to split, right? Going to split into 2 parts. So maybe that 4x minus 8 itself is strictly less than 16. I mean, that could work, right? Suppose this comes out to like 10. The absolute value of 10 is 10, and that would be less than 16. Okay, we're all good there. Okay. Oh, okay. Here's where this gets a little tricky. No, there's like one of 2 different ways this is taught. So you can say, take the 4x minus 8. Okay? I could either make this negative and say it's less than 16, or I could switch the inequality sign and say greater than negative 16. Like if I want to make this negative, say before when I was just doing equals, I didn't have to worry about switching the inequality sign. That wasn't an issue. But we have an inequality sign. Okay, either here, I'll write it this way. You could possibly just could say negative of 4x minus 8, and then keep the inequality sign like it was originally and leave this as 16. Okay? But you guys know if you divide both sides by -1, the inequality changes direction. Right? Okay. So you could cut straight to the step, that's fine, or maybe you want to do the step first and then go to the step. So it's up to you. But here, I'll play the rest of this out and then you'll see how this works. Of course, we're solving for x. Okay? So the obvious solution here, we could do plus 8 and then, yeah, plus 8. All right, so that's 4x is strictly less than, is that 24? Okay. And then divide both sides by 4. So x could be strictly less than 6. Okay. Now, that's not the whole solution, but that's part of the picture. Okay. Over here, if I do plus 8, right, then I got 4x is strictly greater than, this would come out to like -8, I think. Right? Now here's where, oh no, never mind, sorry. Okay, we're good, we're good. Right, so divide both sides by 4. Right, so I'm getting x is greater than that -2, right? Right. Now, x less than 6, but also greater than -2. I think that creates a little window of possible values, kind of like with the football pressure. It can be greater than something, but less than something else, and there's like a little allowable window. Like, I think that's what this is going to look like. So, take a number line here, right, and then we'll test the values out. So I can go as small as -2. Well, okay, it can't be -2, but it has to be bigger than that. So let's have this -3, -2, -1, 0, 1, 2, 3, 4, 5, keep going, 6, 7. I got here. -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Okay. Right, now I'm not allowed to include those values themselves. So at -2, I'll have that as an open circle. The same thing at 6, open circle. Right? But anything in between should work. Right? So hold everything strictly between those numbers, not including the endpoints themselves. So here, let's test some points. Like, let's test 0. 0 should be one of the solutions. So if I plug in 0 up here, let's say this comes out to -8, then the absolute value of -8 is +8. 8 minus 5 is 8 minus 5, which is 3. Is that less than 11? Yeah, that works. So check. So just check 0, that works. Let's check another one that should work. 5 should work. Let's see if 5 works. 5 times 4 is 20 minus 8. 20 minus 8 is 12. 12 minus 5 is, it's 7, right? 7 is less than 11. Yeah, that works too. Check. Right. Now 7 should fail. Let's see, does 7 fail? 4 times 7 is 28. 28 minus 8 is 20. Absolute value 20 is still 20. 20 minus 5 is 15. Is 15 less than 11? No. All right, so 7 definitely fails, which we thought it would. I'm just checking. Now we go back the other way. What about -3 should also fail? 4 times -3 is -12 minus 8 is -20. The absolute value of that is +20 minus 5. Oh, that's what we got before. Is 15 less than 11? No. Really? Number. Right. Yeah. All right. So I just ran, I know I just did those verbally, those 4 checks, but yeah, that aligns exactly with this. Okay. I could also write this in set builder and interval notation. So in set builder, it looks like, let's see, x such that an x has to be strictly greater than -2 or strictly less than +6. Okay. And an interval notation. Okay, I'm not going to use the square brackets because I'm not allowed to include the endpoints, but I can do open parenthesis. And then I'm allowed to go -2 all the way up to 6. Right, so anything between those, not including the end values. Right? Right, so there you go. Right, how about, let's see, is this one different? Okay. Yeah, yeah. I think this is going to give us one of these split intervals, I think, if I remember right. Yeah, let's see. Let's try it out. Example 6. We got absolute value of 6x plus 3, all divided by 2. Okay, so absolute value of that divided by 2, and then plus 5 is going to be greater than or equal to 14. Yeah, I think as a general rule, or good rule of thumb here, whenever you see an absolute value and it's greater than something, I think that's where it's going to split the number line for the solutions. Okay, let's try that. So I'll subtract 5 from both sides. So that'll be 6x plus 3, absolute value, all divided by 2, is greater than or equal to, that would be 9. I'll do times 2 on both sides, times 2 times 2. So absolute value of 6x plus 3 is greater than or equal to 18. Okay? And here's where it splits, okay, into 2 different stories. So the 6x plus 3 itself might be greater than or equal to 18. Like that could definitely work. Like if this all comes out to like 22, 20, yeah, absolute value of 22, still 22, greater than 18, works. Right? Right. Now here's the tricky one, is what if all this stuff was like the negative value. So what if I go 6x here? Okay, two ways you can do this. Okay. You can do the negative of 6x plus 3, okay, and then keep the inequality sign like it is, and keep going. Okay. Or alternatively, you cut straight to this. It's perfectly fine. You could do 6x plus 3, and then swap the inequality sign and tag the negative over here. Okay. So, like if you divide those sides by -1, it could lead you from here to here. Or if you went straight from here to here, I would give you credit for that. That's perfectly fine too. Okay. All right. So let's continue on. We'll do the same thing, get a number line solution, go back, check the solutions, make sure they work, but we'll do. All right, so let's see, minus 3. So 6x greater than or equal to 15. Are they giving us weird fractions? Is that what they're doing? Well, okay, so let's go with it. So divide both sides by 6 over 6 over 6. Now, do you see these are both multiples of 3, right? So, there. Should divide by 3. That would be 2, 5. 5 over 2, I think, right? X could be greater than or equal to. I think this reduces to 5 over 2. 5 over 2, that's about right. Okay. How about over here? Let's see, minus 3. So 6x less than or equal to -20. Oh, this is going to be another weird fraction too. Again, these are both divisible by 3. So this could look like 2x. This could look like -7. So x would be less than or equal to -7 over 2 is how it would work out. Right? Can sort of skip a step there because I'm getting the bottom of the paper. Right? But I think those should be the solutions. Now, yeah, we have x is greater than a positive number or less than a negative number. Ooh, or equal to. There you guys see it. So on a number line, this should split the number line solutions. Okay, so what would that look like? Okay. Right, so let's say I got right, 0 is about here on my number line. Okay, and 5 over 2. Here, let's write in. This could be 5 over 2 or 2.5 if you like. Okay, and then back over here, it's going to be -7 over 2 or -3.5 if you like. Right, right, those are the two. Right? So see, greater than or equal to the big one, or less than or equal to the negative or positive one, negative one. Right? So that would look like, okay, greater than the positive value would be this set of values over here, right? And we're all allowed to include the number because it was greater than or equal to. In there, okay. Could be this value or anything less than this. Right, so full laws and right, something like that. Right, something like that. So that should be the solution. Here I'll do right, and set builder. This would look like uh, x such that okay, x could be less than or equal to -7 over 2. Right? Or x could be greater than or equal to 5 over 2. And an interval notation, I could go -infinity to -7 over 2, right? Close square bracket, and put a union. Right? So union of this and this. Open square bracket, 5 over 2, and then it could just keep going on forever. Right? Let's I still have to test a couple of points to make sure this works. So let's test, how about like -10, 0, and +10? Because if x is -10, that should work. It's part of this interval. If x is 0, it should fail. And if x is +10, that's clearly on this side, so it should work. So let's see if it does. So back to the original statement. If I plug in -10 here, this would be -60 plus these like positive, or sorry, well, -57, but then +57 is absolute value. Divided by 2. Right, well, 57 over 2 is just a big number, 28 point something. If I add 5 to that, it gets bigger. It's definitely bigger than 14, so that works. Check. Bing, it works. Yeah. Let's plug in 0 though. Now, if I plug in 0, this should fail. Let's see if it fails. 0. So this would 0 out, plus 3. Okay, so this is the absolute value of 3 is just 3. 3 over 2 is 1.5. If I add 5 to that, is 6.5 greater than or equal to 14? No, not at all. So this definitely failed, which I was hoping it would, because that's what my solution says. Right, so it definitely failed. That's good. And then +10 should be part of the solution. So if I plug in 10 here, right, I get 63, which is a really big number, divided by 2. It's like 30 something, plus 5. Definitely bigger than 14. Yeah, this one also works. Check. And so we're good. That's the solution right there. Solution. Okay. And okay, let's keep going on. Um, all right. I'm going to do number 7, 5, and 3 in that order. So let's do that. So number 7, I got 5 times absolute value of 2r and then plus 3. And the whole thing minus 5 is equal to 0. Okay? Okay. Solve each equation, check solutions. Right, so we're solving for r, right? R is kind of like s. Okay? So first thing is add 5 to both sides. Let's get 5 times absolute value of 2r plus 3. Right? That's equal to 5. Right? Maybe I could divide both sides by 5, which makes 1. Right, so absolute value of 2r plus 3 is equal to 1. Okay, here's where it's going to split. Okay? And maybe 2r plus 3 itself is 1, because that could definitely work. Absolute value of 1 is 1. But maybe 2r plus 3 is negative 1, and that would also work. Right? Okay, so minus 3. So 2r is equal to negative 2. Divide both sides by 2. R equals negative 1. Go over here. Subtract 3 from both sides. 2r is negative 4. Divide both sides by 2. R equals negative 2. Interesting. Two negative solutions. Okay. Does it actually work? Let's try that. So if I take negative 1, plug it into here, 2 times negative 1 is negative 2, plus 3 is 1. Right, 5 times 1 is 5, minus 5 is 0. Yeah, so that works. Check. And what about negative 2, though? Negative 2 is negative 4 plus 3 is negative 1. Absolute value is positive 1. Times 5 is 5. Minus 5 is 0. Yeah, that works too. Check. That works. Let this work. Right, and I showed you guys earlier how to do a set builder and interval notation. We've done a few of those, so you could also write them. Or how about, what am I thinking of? Right, I'm being silly. I could do, I could write like this. I could write the solution. It could be negative 1 and 2 and curly brackets. Whenever we have curly brackets, isn't that discrete? Uh, discrete solution. Okay. All right, let's do number 5. So it'd be 7, 5, and 3. So we're on number 5. And so 2 absolute value of 4 minus n, and being like x equals negative 3n. That's interesting. Okay. Now right away, I see I have an absolute value, which makes something positive. I got negative of something up here. I sort of see from the beginning that it has to be a negative value, because a negative times a negative can make a positive, which would be the only thing that could possibly satisfy an absolute value. Okay. So I know from the outset it has to be negative. Okay. So, well, maybe I'll divide both sides by 2 to start. Over 2, over 2. Okay, so I got absolute value of 4 minus n, okay, which, by the way, is the same thing as absolute value of n minus 4, if that helped. Right? Absolute value would be the same. This would be negative 3 over 2 times n. Okay. All right, now split this. So 4 minus n could be negative 3 over 2n, or 4 minus n could be positive 3 over 2n. Okay. Still solving for n. Okay, let's get all the n's together. So plus n, and then, well, same thing here, plus n, plus n. Okay. Now, n is the same thing as 2 over 2n, if that helps, like get a common denominator. Okay. Right, so, right, so 4 equals, okay. See, if I have negative 1.5n and I add an into that, isn't that like negative 0.5n or negative 1 half n? Okay. Then on this side, 4 equals, if I have 3 halves and I add another 2 halves, that gives me 5 halves of that n. Right. Still solving for n, still keep going. Multiply both sides by negative 2. I'm getting negative 8 equals n. Okay, so that looks good so far. And then over here, times 2 would be 8 over 5. 8 over 5 equals n. Right? Okay, but you guys remember when I started this puzzle out, I was saying, well, intuitively, I see that n had to be negative. This negative negative would make positive. That's the only thing that could ever work, right? I'm getting one negative answer, which looks good, but what's with this one positive? I don't think that's actually going to work. Let's try that. So what if I plug each of these in? I think this might be an extraneous solution. Right? So let's plug negative 8 in here, see what happens. So 4 minus 8 that would be -4. Absolute value is +4. Then say, take this 2 times this 4, then divide by 2, right? That would give me 4, right? Right. So you get 4, like a coordinate. And then over here, what if I have -3 times -8? That that works. Oops. Let's see what happened there. Oops. I should have written this down. Okay, I just said something a little wrong. Okay, I think this will still work. I just said something wrong. So it's a good thing you just 4 minus -8. Okay, I gotta be careful with my negative footwork here. Okay, is that equal to -3 times and then -8 over here? Okay, so is it? Let's find out. Okay, so all right, 4 minus -8 is not -4. What was the thing? This is 12. This is 12, isn't it? Because isn't this 4 plus +8 is 12? This is all 12 right here. Okay. Times that 2, it gives me 24. So is 24 equal to -3 times -8 is 24? Yeah, that checks out. Check. Okay. So -8 does work as a solution. Okay, so -8 works. I think this one's going to fail though. I think, here, sorry. So what if I plug in 8 over 5? Okay, so 4 minus 8 over 5, that's 2.4. Right? So times 2, that gives me 4.8. Right? So drop down 4.8. Okay. Is that equal to, and then on this side, -3 times 8 over 5 is -4.8. Yeah, that didn't actually work. Okay, so is 4.8 equal to -4.8? No. So this would be an extraneous solution. That's to say that it's not actually a solution. It doesn't actually work. So the answer is n equals -8 is the only solution. Right? That's it. There's only one solution to that. Right? Wonder what that would look like on Desmos. All right, so I said y equals the left expression, y equals the right expression. I got, oh, wait, what is this? Hold on. I don't know where that came from. Whoops, sorry, wrong graph. Right, here we go. That was something else. Got a few of these queued up. Okay, yeah. Okay, so it'd be this right here, wouldn't it? All right. Yeah, so I see a V curve and I see a straight line, and they do only cross at, come on here, at one place. So there is one solution. It should be x equals -8. Bing. Yeah, it is. It sure is. X equals -8. Right. Uh, what else we mathematically there was like an 8 over 5, which is like 1.6, I think. Actually, if you extrapolate this like down, it looks like it would have crossed this black line, probably pretty close to that. Although it doesn't actually, right? Because it's a V curve. Right. Yeah, that's exactly what we got with the math. So that checks out. All good. All good. Let's keep going. I need to do number 3 with you guys. Right, so we did 7 and 5. Now let's do number 3. Number 3. Right, so I got 4, and then that's the value 2y minus 7, and then plus 13 is equal to 9. All right, so let's run this. So let's see, subtract 13 minus 13. Right, so I'm getting 4 times absolute value 2y minus 7 equals, this would be -4. Ha. Look, I got an absolute value of something is equal to a negative value. That'll never happen. So I can say there's no solution. Right? You can also say y equal, because we're solving for y, right? Solving for y. Okay. You could write it this way. Right? Or you could write it this way. Okay. So each of these is called the empty set with set, which is another way of saying that there's no solution. Okay, so here's 3 different ways you could write the answer. There's no solution, empty set, empty set. Okay, there you go. So number 3, there's no solution. Okay, number 10, opinion poll. Public opinion polls reported in a newspaper usually given with a margin of error. Right, so a poll for, say, a local election determined candidate Morrison would receive 51% of the votes. Ooh, tight race, 51%. because there's a margin of error, plus or minus 3%. Maybe they can only poll like a few hundred people, right? Right. Write and solve an absolute value equation to define the minimum and maximum percent he would be expected to receive. And maybe you can sort of intuitively figure out, see, it's 51% plus or minus 3%. Shouldn't that be like between what, 48 and 54%, something like that? Right. But let's do this systematically. So I think that um, the percentage they should receive should be equal to 51% plus or minus 3%. Right? Isn't that turned to an equation exactly what they said? What's your percentage? 51% plus or minus 3%. Okay. Right. Now let's subtract off 51%. So you can say x minus 51% equals the plus or minus 3%. Now I have the plus or minus bit all isolated. So now I can turn this into an inequality, or sorry, absolute value. So the absolute value of x minus 51%, right? Like x being what percent actually supported, like by the time that people actually go to the polls and cast their votes, right? Okay. Well, actually, I will change this equal sign to an inequality. Because if I left it as an equal sign, I'd be saying that you'll either get exactly 48% or exactly 54%. No, that's not what I'm saying. I'm saying you can get anywhere between that like range of values. So this difference, absolute value, has to be less than or equal to 3%. Right. So now we lost the plus or minus, but we sort of replaced it with this absolute value paired with that inequality. Wait, is that what we need to do? I think that's I think that's all we need to do, right? X minus 51. Yeah, okay. Well, I'll make a number line and separate too, right? But I think that should take care of it. Okay. So, where'd my ruler go? Ruler, no, find my ruler. Arr, found it. Right, so if I have, let's say 48, 49, 50, 51, 52, 53, 54. Right? But if you kept going, it could be like a 55, 56, and the other way it could be like a 47, 46. Right? So this could keep going to the left, keep on going to the right. Right? Oh, all right. So 51% should be part of the solution set. Now this could go as low as down to 48 because that'd be 3 that way, and as high as 3 this way brings you to 54. Right? It could really be anything between here and here. So if you need 50% to win the election, which is right here, I mean, just kind of eyeballing my number line, I say, there's probably like a 2/3 chance or so he's going to win this election. Because, I don't think it's exactly correct, but you guys get the idea, right? Right. There's a lot more that's in the winning territory than in the losing territory. Okay. All right. Let's see, does this work? So let's say, suppose it goes to the polls and actually gets 53%. Does that agree with us? 53 minus 51, that'd be 2. So is 2 less than 3? Yeah, that works. That works. It's nice. But if you went to the polls and got like 55%, that would not be indicated by this expression. So does 55, it should fail. 55 minus 51 is 4. Is 4 less than 3? Ooh, yeah, okay. So this is exactly it. Right, and set builder, I would write this as x such that, see, x is between 48 and 54%, right? Inclusive, right? In interval notation, I would write it as square bracket 48, comma 54. Right? So here, there's 4 different ways to write the solution. There's 4 different ways. Right? Absolute value inequality, there's a number line, there's set builder, and there's interval notation. 4 different ways to do that, to express that. Right. All right. Solve each inequality and graph the solution set on a number of All right, so we'll solve and graph. No, I chose 4 here. Why did I choose so many? No, well, do a couple with you guys anyway. Submit here. Yeah. All right, so let's do number 11. I got absolute value 2x plus 2, and then minus 7 is less than or equal to -5. Okay. So what does this look like? Okay. So plus 7, plus 7. So you got 2x plus 2 inequality is less than or equal to, this would be 2. Okay. And then this is going to split into maybe the 2x plus 2 is less than or equal to 2. Or maybe the 2x plus 2. Uh, okay. You could say the negative of that is less than or equal to, or you could just jump straight to this. The 2x plus 2 itself would be greater than or equal to 2. Notice the inequality. Switch, and the other side is negative. Okay. And divide by this by negative 1. And so minus 2, minus 2. So 2x less than or equal to 0. Therefore, x is less than or equal to 0. Right, and then over here, let's see, minus 2, minus 2. 2x greater than or equal to negative 4. Divide by size by 2. X greater than or equal to negative 2. Okay, so it's has to be bigger than or equal to negative 2 and smaller than or equal to 0. Right? Yeah, on a number line, that would go negative 3, negative 2, negative 1, 0, 1. Okay, keep going, keep going. Okay. All right, so 0 works, negative 2 works. Right? Anything bigger than negative 2, smaller than 0. Right? That's all this bit right here. That's it. Right? On a number line, it's like that. Um, Right, so negative 1 should work. Let's see if negative 1 works. So if I plug in negative 1 up here, get 2 times negative 1 is negative 2 plus 2 is 0. So this whole thing would zero out. Okay, minus 7. So is negative 7 less than or equal to negative 5? Yeah, it is. Yeah, so negative 1 works. Okay. The number 1 should fail. So this would be 4. 4 minus 7 would be negative 3. Is negative 3 less than negative 5? No. So that's good. Negative 3 should also fail. So this would be negative 6 plus 2 is negative 4. The absolute value is positive 4. Minus 7 is negative 3. Is that this negative 3 less than negative 5? It is not. Yeah, so this exactly works. All right, so let's do number 12. Number 12. I got absolute value x over 2, and then minus 5, plus 2 is greater than 10. Okay. All right, so subtract 2, subtract 2. So we got absolute value is greater than. Okay. Guys, remember, when we saw this before, whenever you see an absolute value is greater than something, that's probably going to split the number line. We'll have to like throw a union in the interval notation for the solution, I think. Yeah, well, let's see. Right, so this could be x over 2 minus 5 is strictly greater than 8. That should work. Right? Or maybe I have a negative of x over 2 minus 5 is also strictly greater than 8. Or if you like, x over 2 minus 5 is less than negative 8. Right? So now let's see, plus 5, plus 5, plus 5, plus 5. So it's going to be x over 2 strictly greater than 13, x strictly greater than 26. Over here, x over 2 strictly less than negative 3, x strictly less than negative 3 over 2. Make sure I'm getting this right. 6. Oh, I'm sorry. Whoops. Negative 6. Right? What am I thinking? If I multiply. Okay. Okay. All right. So less than negative 6, but also greater than 26. Yeah, that's going to be a split number line, isn't it? All right. So, like if 0 is here and negative 6 is here, 26 is probably about here. Right? So strictly greater than 26. So open a circle that's strictly greater than. It could be anything bigger than that. Right? At 6, open the circle. It could be anything less than that. Right. So let's pick 3 points to test them. Like 0 should fail. A huge negative number should pass, and then anything bigger than 26 should pass. So does 0 fail? Let's see if 0 fails. So 0 to 0 minus 5 is negative 5. Absolute value is positive 5. So this whole thing would be 5. Plus 2 is 7. Is 7 greater than 10? It is not, so 0 does fail, which is good, right? Because we thought it would. Right? What if I plug in like -10? So -10/2 is -5 minus 5 is -10. Absolute value is +10 plus 2 is 12 greater than 10? It sure is. So that works. Yeah, it works. How about 30? So 30 divided by 2 is 15 minus 5 is 10. Okay, so plus 10 plus 2 is 12. 12 is greater than 10. Yeah, that also works. All right, so that's exactly it right there. And here, so to write this domain out, I could say domain and set builder notation could go x such that x is strictly less than -6 or x is strictly greater than 26. And in interval notation, I could write it as -infinity to -6 and then close parenthesis. And then union, and then it picks up at 26 and goes on to infinity. Right, so there you go. There's 3 different ways to write the solution to that. Right here, let's get a couple here. Let me do, I got a bunch highlighted here, but let me check how I'm doing on time. I see that. You know what? I've not been keeping track of time. I don't know how much time's been going. So I'll just do a few though. I kind of feel like I'm gonna be doing a lot there. Maybe I'll do manufacturing. I'll do this one. I'll do projectile. And I think that, yeah, I think that'll definitely cover everything. I'll just do these 3 and close out. So let's do number 20, manufacturing. Food manufacturers guidelines state that each can of soup produced cannot vary from its stated volume of 14.5 fluid ounces by more than 0.08 fluid ounces. Okay, so there's a little plus or minus. Okay. Right, solve an inequality. And okay, graph on the number line. Right. So the can of soup, maybe I'll do V for volume. Okay. Should be equal to ideally 14.5 fluid ounces. So OZ for ounces, right? Plus or minus 0.08 ounces. Right, so that. Okay. So let's do some algebra here. I'll drop the units, but you guys know the numbers refer to ounces. Subtract here over 14.5. So the difference between the actual volume and the ideal volume of 14.5 ounces, okay, should be less than or equal to 0.08 ounces. Okay? So for example, if this was like 14.51 minus 14.5, that'd be 0.01, which is less than 0.08. So that would be fine because that would work. That would be within that window. If this was like 20 ounces, 20 minus 14, okay, now it's like 5 or 6 ounces. It's definitely not less than 0.08. Right. So yeah, that'd be like way not good. Right. So we got this as a solution. What else did they ask for? So is it as an inequality? Okay. Oh, we graph the solution on a number line. So on a number line, let's go like, well, let's see, it'd be 14.42, 14.50, 14.58. Okay. So we're allowed to have it from here to here. Yeah, so this is what it would look like on a number line. Okay, like that. All right, let's go to number 25. 25. All right, so they have this word puzzle. They want you to translate this into math, what this would look like mathematically. It says the absolute value of, so number 25, of the sum of. So the absolute value of the sum of 4 times a number and 7 is the sum of 2 times a number and 3. Okay, sometimes there's tricks to pick this apart, but here, I'll do my best here. Okay, so absolute value of this, okay, the sum of 4 times a number, here, maybe I'll start with that, 4 times a number. So 4 times the number, say x could be a number, and 7, the sum of 4 times the number and 7. So there's 4 times, sorry, there's the sum of 4 times the number and 7. Okay, and I need the absolute value of that. Okay, it says is the sum of, so is, right, the sum of I'm adding things together, 2 times the number and 3. If it's the same number, then this x would be this x. And so 2 times the number and 3. Right, let me double check. I think that's the solution they're looking for. Let me make sure it works. Let's see, the absolute value of the sum of 4 times the number 7 is the sum of 2 times that number and 3. Yeah, that should be it right there. Okay. And last one, 37, projectile. I have to do projectile because my other main class is physics. So this looks exciting. An object launched into the air and then falls to the ground. Its velocity can be modeled by, let's see, this equation. We got velocity equals 200. Okay, that would be in feet per second. So right, if this were a physics class, I would definitely write feet per second, but I'll just leave that off. Then minus 32t. Oh, by the way, I know what 32 is. That's feet per second squared. That's Earth gravity. So that would be true. Yeah. So this is like if you threw an object straight into the air. It's like slowing down with time, and then eventually it comes down and like picks up speed because gravity's like pulling down. Okay. But, see, the object's speed is the absolute value of its velocity. Right? And solve a compound inequality to determine the time intervals in which the speed of the object could be between 40 and 88 feet per second. Interpret your solution in the context of the situation. Okay. So maybe I'll change this V to an S for speed. S for speed. Okay. Speed is just the absolute value of velocity, which means that it doesn't matter if it's going up or down. See, like here with velocity, if you threw an object straight up and it's moving up versus if it's coming back down, there'll be two different directions. You can interpret that as a positive or a minus. The reason this is actually a really good example for absolute value is that the speed is just the positive value. Like you don't really care if it's going up or down. So just the absolute value of 200 minus 32t, like that. Yeah, like that. And we're looking for the times that it's okay between these two particular speeds. Uh, hmm. You know what? Just here, if I kind of draw out a picture. Um, all right, I'm going to start over with my picture. Right. I really want you guys to think about this picture though. Right? Let's say you were on flat ground. You throw a ball straight up in the air. Right? And it starts off at like 200 feet per second. So it's zooming really fast, right? Then as it's going up, isn't it slowing down? It goes slower, 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 slower. And then it peaks and it has like zero speed just for one instant. It comes down faster, 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 right? And it hits the ground. I bet it's crashing to the ground, 200 feet per second, but now it's going down, right? As long as there's no air drag, which I think this model's of it. Now, they're looking for between two particular speeds, between 40 and 88 feet per second. So I'm thinking maybe when it hits about here-ish, maybe it's going like 88 feet per second up. And maybe when it's here-ish, it's going like, let's say 40 feet per second. I don't think my drawing's exactly at scale, but you get the idea. This is slowing down, like 200 here, 88 up here, 40 up here. And then when it comes back down, it's going like 40 feet per second down here. And then it hits here, it's picking up even more speed. Now it's going like 88 feet per second. Okay? So they're looking for the times where it's between those speeds. So I think between this time and this time, and also between this time and this time, that would both be true, wouldn't it? Right. So I think on the number line, that would show up as two distinct time intervals, right? Like if you're timing this, looks like pretty quickly it's between those two speeds. And then that for a while it's going way too slow. And then it comes back and it reaches those speeds again for a different time interval. Okay? So we should see that reflected in the answer. Oh, let's see. Let's see. Does math actually work? We're going to find out. So take 200 minus 32t. So that absolute value. We want that absolute value to be, is it strictly greater than or is it greater than or equal to? Between, well, maybe it's kind of interpretation. All right, I'll say strictly greater than. Let's say strictly greater than 40 feet per second and strictly less than 88 feet per second, or something like that. Okay, those time rules. Now here we gotta split this, right? So got 40 is less than. Now if this was already positive, then it'll just be 200 minus 32t, and then that would be less than 88. Right? But right, what if this comes out negative and you have to negate it? Now here's where okay, I'll throw in this extra step. This negative of 200 minus 32t is between 40 and 88. Or you could flip the inequality sign and say negative 40 is greater than, and then this would come up to positive. So 200 minus 32t. See how I divided all three sides sort of by -1. So it makes this negative, flips this inequality sign, flips this inequality sign, and then this would be -88. Okay. So it could be greater than -88 and also less than -40. Yeah. Okay, so okay. I think that on my picture that sort of probably refers to like this time interval here, probably. If well, yeah, it's probably. All right, so let's finish solving this then. So I can subtract 200, or I can do the same thing over here. Subtract 200 minus 200 minus 200 minus 200 minus 200. Okay. So it's sort of like three sides here and three sides here. Think of it that way. So I'm just following algebra rules, I'm just subtracting out 200. So that gives me -160. Did I do that right? Okay. Less than -32t, solve for t, less than 88 minus 200. This would be -112. Right? Right. And then over here, I get -240 is greater than -32t is greater than -288. Okay, we can do this right. See, divide all sides by -32 over -32 over -32 over -32 -32 -32 -32. All right, so 160 on 32. So I'm getting 5. Now remember, when you divide by negative, don't all the inequalities swaps direction? Okay, so this becomes the greater than t, and then this would also change. And then 112 over 32 works out to 3.5. So the time's between 3.5 and 5 seconds on this side. And over here, 240 over 32. Look at it, 7.5. And this changes direction. This is just t. And then 288 on 32 is 9. Right. These would be seconds. Right, so numbers of second. I'll spell that out, sort of. Seconds. Right, so these are all seconds. Seconds, right? So the time can be between 3.5 and 5 seconds. So that lines up with my picture right here. Or it can be between 7.5 and 9 seconds, which lines up with my picture right here. Yeah, there it is. There's the two parts of that picture. So the solution should be, this is what, number 37. Let me check. Boring. Yeah. Yep. That's working. Okay. So on a number line, right? If I got like time in seconds, maybe I'll start at 0, right? Okay. If I go from 3.5 to 5 seconds, this might not be exactly to scale, but just get the idea. 3.5 to 5, and then 7.5 to 9, okay, something like that. So between 3.5 and 5, right? That's where maybe it's heading on the way up, slowing down. Between 7.5 and 9, that's where it's coming down, speeding up. Right? That could be a decision. And set builder notation, I would say time such that, let's see, 3.5 less than t less than 5, or 7.5 less than t less than 9. And in interval notation, I would go 3.5 to 5, it's between those speeds, close parenthesis, right? And then union, and then 7.5 to 9. All right, so that should cover it right there. That'll do it.